All right, so this one says the graph models an approximate number of tickets sold, T of X, at the movie theater each day, X after the movie was released. So I think X represents the days after the movie was released, and the Y axis, which is T of X, represents the total number of ticket sales. And then, so there's the graph of that. And then it says determine the approximate range or the approximate average rate of change in the number of tickets sold between the 3rd and 10th days after the release. So what you do is we're going to determine we're going to find the points and calculate the slope. All right. Now, is that exactly what it is? No, that's why they call it an average rate of change. So I'm going to come to the 3rd day right here when X equals 3. It looks like T of X. So we're going to write down what X is and what T of X is. Now we're used to saying X comma Y, but now we're a little more formal in Algebra 2, right? We're trying to get you ready for the next thing. You guys are used to this X comma Y, right? But we're going to, Y is the value of X, of that, calculated based on a formula. Well, if that formula is a function, which is a very specific type of equation, then we use the notation T of X. So what is that? Well, it looks like it's at 3, 100, right? And then we're also going to look at the 10th day. Well, what is that? 10, it looks like 80. So now remember to when we talk about the rate of change in any function, what we're really trying to do is determine the slope. So that is really just the slope. And remember, the slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay. So we could think of this as like x sub 1 comma y sub 1. And we can think of this as x sub 2 comma y sub 2. I like to write this out because then I'm less likely to make a mistake. So I'll say x sub 1 equals 3. I'll say y sub 1 equals 100. I'll say x sub 2 equals 10. And y sub 2 equals 80. Okay. And I'm going to double check. X sub 1 is 3, y sub 1 is 100, x sub 2 is 10, and y sub 2 is 80. So now to calculate the rate of change, I'm going to plug in y sub 2, which is 80. And then I'm going to subtract from it 100. Right? Because that's y sub 1. All over x sub 2, which is 10, minus x sub 1, which is 3. Okay? So then I'm going to have 80 minus 100 is a negative 20 all over 7, right? 10 minus 3. So now if I plug that in the calculator, oh, gotta wait for my calculator to load up. Oh, there it is. Thought I was going to have to use the actual calculator. So let me just show you this real quick. So if I say negative 20 divided by 7, I'm going to get pretty darn close to negative 3. Okay. So that whole thing's about negative 2.86. I'm sorry. So this is approximately negative 2.86. I couldn't round that up to negative 3. So now the question is determine the average rate of change. I think it's D, right? The number of tickets sold changed by an average of approximately 3 tickets per day. Now, the negative number just represents that the total tickets sold went down, right? So this means a negative slope really just represents a decrease in sales of tickets. So on the first day, they sold the most amount of tickets. On the last day, they sold less tickets. And the day after that. So every day it decreased. So the slope then was basically from the third to the 10th day, about 3 tickets less. Okay. So it's about 3 tickets. Okay. If we were to round that up to the nearest whole number. This thing is going awfully